We're down to the final section. It says the argument in item 5 shows that there is a sequence of rigid motions that maps triangle ABC to triangle DEF. Specifically, the sequence of rigid motions that maps AB to DE, followed by the reflection across ED, maps triangle ABC to triangle DEF. And by the definition of congruent, triangle ABC is congruent to triangle DEF. Now you can use the side, and angle congruent criteria to prove that triangles are congruent. Greg knows that point X is the midpoint of JK in the truss shown below. He also makes measurements and knows that JL is congruent to KL. He must try to prove this. He must prove to his boss that triangle JXL is congruent to triangle KXL. And it walks through a proof, and it starts by saying K is the midpoint of JK. JL is congruent to KL. So we start off with line 1 saying K is the midpoint of JK. X is the midpoint of JK. Given. Then it says JX is congruent to KX by the definition of midpoint. Then it says JL is congruent to KL, and that was given. The last thing we know is we know that LX is congruent to LX, and this is called the reflexive property. It's the same line, so it has to be the same measure. Well, we've proven these sides are congruent. I'll mark those. So we've proven these sides are congruent. We've proven these sides are congruent. And we know that this is congruent to itself. So we can use the side congruence to prove that those two triangles are indeed congruent. On the next slide, what you will see is a drag and drop that goes along with question B. It goes along with question B. So give yourself A. So give yourself about 5 minutes to work through that before you move on to your drag and drop. Good luck.